Okay, so for our first review, we're going to be talking about polynomials. Let's first define some of our terms. A term we define as a variable, a number, or product of variables and numbers with whole number exponents. So we look at this example and we think about what it means. I have an example written up here for you. Negative 3x squared plus 6x minus 9. Minus 9 is a number, so that's a term by itself. 6x is a product of a number and a variable, so that's its own term. And negative 3x squared is also its own term. These are separate terms. So next we have coefficient, which is the number in front of a variable. We have some coefficients here. I have negative 3 is a coefficient because it's in front of x squared. I also have 6 is a coefficient. It's in front of x. Polynomial we define as a monomial or a sum or difference of monomials. So up here we have an example of a polynomial. It's made up of a bunch of monomials. Monomials are different terms which we just defined above. Degree of monomial is going to be the sum of the exponents of the variable. So for example, in negative 3x squared, that's a monomial. The degree is going to be 2 because that is my exponent. In 6x, the degree is going to be 1 because I have an exponent of 1. Now the degree of your entire polynomial is going to be the highest degree of its terms. And it's usually your highest exponent. So when we take a look at the entire polynomial above, it's going to have a degree of 2 because that is my highest exponent. Standard form of a polynomial is when the terms are written in order from greatest to least. And by that I mean we're taking a look at the exponents. So the exponents are in order from greatest to least. Okay, and your leading coefficient, it's easiest to identify this when your polynomial is in standard form. It's the number in front of the first term when the polynomial is in standard form. So in this case, our leading coefficient will be negative 3 because that is my first coefficient and my polynomial is in standard form. Okay, let's continue defining our terms. Polynomials can be classified by the number of terms it has or the degree. So if a polynomial has a degree of 0, we call that a constant, meaning it has an exponent of 0. Okay, that's just a constant or it's just a number. If a polynomial has a degree of 1, that is a linear polynomial. Okay, linear, just like when we deal with lines, we have an exponent of 1, it's a linear polynomial. If it has a degree of 2, meaning an exponent of 2, that's going to be a quadratic polynomial. And if it has a degree of 3 or a highest exponent of 3, that's going to be a cubic polynomial. The other way we can define polynomials or classify them is by the number of terms they have. So if a polynomial only has one term, we call it a monomial. So keep in mind that these are all polynomials, but the more specific name is going to be monomial if it has one term. If it has 2 terms, it'll be binomial. If a polynomial has 3 terms, we call that a trinomial. And we don't have any more specific names for 4 or more, so those are just known as polynomials. So again, we call all of these polynomials as we walk through this worksheet, but some of these just have more specific names. Okay, so let's practice what we just learned. This part of the worksheet says, write each polynomial in standard form, identify the degree of the polynomial, classify the polynomial by the number of terms and degree, identify the leading coefficient. So the first thing we want to do is write this in standard form. Keep in mind that standard form means that our exponents go from greatest to least. So I see that my greatest exponent here is the square, the 2, so that has to come first. I bring the entire term to the front. So that's 7x squared plus 4x. The degree of your polynomial is going to be the highest degree. In this case, it's 2. The classification. So first, let's take a look. We have a degree of 2, so I know that's going to be quadratic, but what type of quadratic? There's only 2 terms, so let's look over here. That's called a binomial. So we classify this polynomial as a quadratic binomial. The leading coefficient, since I already have my polynomial in standard form, it's really easy to identify. It's going to be my first coefficient, it's -7. So pause here if you want to try the next one on your own. Otherwise, we're going to keep on going. In standard form, I want to identify my highest degree. That's the degree for the exponent, so that term must come first. 8x cubed, followed by an x squared, followed by a -2x, and then followed by -22. The degree of my polynomial is going to be the highest exponent. In this case, it's 3. If it has a degree of 3, we call that cubic. And then let's count the number of terms we have. We have 1, 2, 3, 4. That's a polynomial. So we have a cubic polynomial. And last but not least, the leading coefficient is going to be the coefficient that's first when it's already in standard form. So I'm looking at my standard form. The coefficient in the front is an 8, so my leading coefficient is an 8. Okay, let's move on to page 2, adding and subtracting polynomials. When we are adding or subtracting polynomials, we can only add or subtract them when they are like terms. Okay, and what does it mean to be like terms? Well, like terms must have the same variable and exponent. So if you don't have the same variable and the same exponent, they're not like terms. You cannot combine them. To add or subtract polynomials, you're going to add or subtract the coefficients. And remember, that's the number in front of your variable, and then you're going to keep the variable and exponent the same. So let's try this first problem together. What is the sum of -3x squared minus 7x plus 9 and -5x squared plus 6x minus 4? We know sum means addition, so we're adding these two terms together. I always like to rewrite my problem. So -3x squared minus 7x plus 9, and we're adding that to -5x squared plus 6x minus 4. Now we're going to look for like terms. Let's take a look at our first one. This one has a variable of x and an exponent of 2. So we're also looking for that anywhere else in this polynomial. And I see that again here, -5x squared. So we're going to add the two coefficients together, -3 plus -5. I get -8, and we bring down our x squared. Okay, let's keep going. -7x, what can I combine that with? Well, that only has a variable of x. It has an exponent of 1. I see that again down here with +6x. So -7 plus +6, that gives you -1x. And then we have +9 and -4. Those combine to give us +5. I like to underline as I go because that way I know that I've used all of our terms. That's our final answer. Let's take a look at our next problem. Subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. Express the result as a trinomial. So what we want to do first is let's write down the problem. If we're subtracting 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7, the front piece has to come first. So it's going to be 3x squared plus 8x minus 7, and we're subtracting the entire thing. 5x squared plus 2x minus 11. Before we can move on, we must distribute. I'm going to bring this down. 3x squared plus 8x minus 7, and let's distribute this negative. There's an imaginary 1 here. So now I get minus 5x squared, minus 2x, and plus 11. So just make sure you're distributing to every single piece. Combine like terms, 3x squared can combine with negative 5x squared. You'll get negative 2x squared. 8x combines with negative 2x, so 8 plus negative 2 gives you positive 6x. And I have negative 7 combines with positive 11. If you add those together, you get positive 4. Okay, and that is our final answer. Okay, now let's multiply polynomials. So let's go down. When we were multiplying polynomials, multiply the coefficients, meaning the numbers in front of the variables, and then you're going to add exponents of the variables, okay? So the variables have to be the same. We also use the distributive property, and distributive property means whatever is outside of the parentheses, multiply inside. So you do A times B, you get AB. And then you do A times C, you get AC. So you use distributive property to multiply. 2 ways we multiply. We use FOIL, or we can also use the box method. And let's practice both on this same problem. X minus 4 times x plus 6. We're first going to practice FOIL. FOIL stands for first, outer, inner, and last. Down. Okay, so we're going to first multiply our first terms. Our first terms are x and x. I get x squared. And then we multiply our outer terms, the terms on the outside, x times 6. I get positive 6x. Now let's multiply our inside terms. So that's negative 4 times x. That's minus 4x. And then we'll do negative 4, our last terms, negative 4 times 6 gives you negative 24. After we multiply, after we distribute, we always have to combine like terms. There's nothing for me to combine x squared with, so let's bring that down. 6x can combine with 4x, you'll get a positive 2x. And then negative 24, there's nothing to combine with, so we bring it down. Let's practice this doing the box method and see if we get the same answer. So when we use the box method, start off by drawing a box. We split the top up into the number of terms we have for our first factor. There's only 2 terms, there's an x and there's a minus 4, so that's going to go on top. On the side, we're going to split it up into the number of terms we have for our second factor. That's also 2, so I split it up into 2 pieces and I get x and a positive 6. Now we're going to multiply to find the area of each box. This box highlighted in red is going to be x times x. I get x squared. In green, I have negative 4 times x. That's minus 4x. In the blue box, that's created with x and positive 6, so that gives you 6x. And then in our final purple box, that's created by negative 4 times 6. That gives us negative 24. Now what we want to do is combine all our like terms. I have x squared, and I have 6x and negative 4x. That gives you positive 2x. And then we have a negative 24. So you notice that both foiling and using the box method, we get the same answer. It's whichever method you prefer. Okay, we're on to our third page. The first problem is a binomial multiplied by a trinomial. Let's first copy down the problem. X minus 2 times x squared minus 7 plus 3x. So you multiply, always start with your first term, and we're going to multiply to every other term in the other factor. So I'm going to do x times x squared. You get x cubed. X times negative 7, that's a minus 7x. X times 3x, that's going to give you 3x squared. And now you'll see there's no more places for me to draw arrows, so now we can move on to our second term. Our second term is negative 2, and we want to multiply everything in the other factor by negative 2. So negative 2 times x squared, we get minus 2x squared. Negative 2 times negative 7, we get positive 14. And negative 2 times 3x, we get negative 6x. Again, after multiplying, we always want to combine like terms, so let's first look. There's nothing that I can combine x cubed with, so let's just bring that down. Now I have negative 7x. I can combine that with negative 6x since they both only have x. That gives you negative 13x. 3x squared can be combined with negative 2x squared to give you positive 1x squared. And this is why underlining helps, because a lot of you would have forgot about the 14, but I see it's not underlined. There's nothing I can combine it with, so let's just bring that down. One final thing I have to do is make sure that my answer is always in the standard form. This is not in standard form. To put it in standard form, put your exponents from greatest to least. My greatest exponent is x cubed, followed by x squared, followed by x, followed by your constant. Okay, so this is your final answer. Okay, let's move on to factoring polynomials. We always want to see if you can factor out a GCF first. After you do that, we create the table of A times C, and it has to add up to B. We expand to 4 terms, and we use grouping to factor. So when we look at this first problem, 2x cubed minus 10x squared plus 12x, you want to ask yourself if there is a common factor between all of these pieces. What can I divide all of these pieces by? Well, I can definitely divide all of them by 2. And I notice they also all share an x, so I can factor out 2x from all of these. If I factor out 2x from the first piece, I'm left with 1x squared. Factor out 2x from your second term, you're left with negative 5x. And factor out 2x from 12x, you're left with just positive 6. Okay, so we're going to hold on to this 2x. Don't forget about it. We need it at the very end. But we're just going to be working with this polynomial inside our parentheses. Let's identify our a, b, and c. Our a is 1, our b is negative 5, and our c is 6. So you're going to make your table of a times c, and we want the number to add up to b. So a times c in this case is 1 times 6, which is just 6. And your b value is negative 5. We start by listing factors of 6, so 1 and 6, or also negative 1 and negative 6. We also have 2 and 3, or negative 2 and negative 3. These are all numbers that multiply to 6. Now we need to check, do they add up to 5? Sorry, do they add up to negative 5? 1 plus 6 gives you 7. That doesn't work out. Negative 1 plus negative 6 gives you negative 7. That doesn't work out. 2 plus 3 gives you positive 5, so we're close, which is why this last one works. Negative 2 and negative 3 give you negative 5. So what we're doing is taking this negative 5, and we're going to break it up using the two numbers that we found, negative 2 and negative 3. So I have 1x squared minus 2x minus 3x plus 6. We factor by grouping here. We draw parentheses around our first two terms and our last two terms. Between the first two terms, you could factor out an x, and you're going to be left with x minus 2. And then the last two terms, be careful because you're factoring out a negative 3, so your signs will change. This is now x minus 2. I know we're on the right track because our parentheses are the same. I see that twice, I'm going to write it once. X minus 2, and your other factor is going to be what's left. Now keep in mind, this x minus 2 times x minus 3 was only the blue part of your polynomial. You need to make sure you bring down that 2x from the beginning. Don't forget about it. So this is what it looks like, completely factored. If you would like to try the next one, go ahead and pause the video now. Otherwise, we're going to continue. X squared plus 3x minus 18, we're looking to see if there's anything I can factor out of all of them. They don't share any constants because that's 1, 3, and negative 18. There's nothing I can divide all of them by, and they don't all share an x. So actually, there's nothing we can factor out as in terms of GCF, so we're just going to get factoring by grouping right away. Our a value in this case is 1, our b value is 3, and our c value is negative 18. So again, let's make our table. We have a times c, and we have b. A times C in this case is negative 18, and our B value is going to be 3. So I need factors of negative 18. Let's start with negative 1 and 18. Also positive 1 and negative 18. We also have negative 2 and 9, or positive 2 and negative 9. We also have negative 3 and 6, or positive 3 and negative 6. So now we go through to see which of these will add up to 3. Negative 1 and 18 gives you 17. 1 and negative 18 gives you negative 17. Negative 2 and 9 gives you positive 7. 2 and negative 9 gives you negative 7. Negative 3 and 6 gives you that positive 3 that you need. So now we're going to take our polynomial from the top and replace our 3x with the two factors that we found. X squared minus 3x plus 6x minus 18. Factor by grouping, let's draw our parentheses. From the first two terms, we factor out an x. I'm left with x minus 3. From the last two terms, we factor out a positive 6. We're left with x minus 3. And again, I'm checking for myself as I go. I know I'm on the right track because my parentheses are the same. X minus 3 will be one of my factors, and your other factor is x plus 6. And we are done. So if at any point you were confused with anything in this video, make sure you bring the questions to class. Also, you can rewatch the video. The last 4 problems are for you to do on your own. Please make sure you show all work. No work means no credit.